Hello friends, I had discussed about the functions in last session and we tried its graphs. Now we'll proceed to the next session or next mathematical tool called as differentiation. Now we'll look at the today's session objectives. One is introduction to differentiation and different rules of differentiation. So first we'll see what is differentiation. Look at this graph. Let's say you have one function y is equal to fx and it has any arbitrary shape. You can look at here, I have drawn this graph. It is little bit parabolic in nature and you can check I had taken 2 points over here. One is P and another point is Q. You can check the coordinates of point P, it's x1 and y1. Whereas if I will take another points on the curve which has coordinates x1 plus delta x and y coordinates it's y1 plus delta y. So approximately I have taken the interval of delta x, right. So now function f of x is equal to y I am saying. So whenever I changes the value of x, its y value will change. So it's very obvious when I am putting x is equal to x1, I get y1 which I have drawn over here, and whenever I put x is equal to x1 plus delta x, we get some another value which is y1 plus delta y. Now what I am going to calculate is how y changes with respect to x, that is delta y by delta x. Now we'll calculate the delta y by delta x over here. So you can look at this function. First of all, I put y1 plus delta y minus y1 divided by x1 plus delta x minus x1. So this y is nothing but function of x. So first value of x is x1 plus delta x. So I used x1 plus delta x over here, and second value is x1. So I'll be putting minus f of x1 over here. Right? If you look at in denominator, it's x1 plus delta x minus x1, right? So same simply wrote over here, f of x1 plus delta x minus f of x1 is equal to delta x. So this also represents the slope of line PQ, right? So that is delta y by delta x is nothing but QC upon its PC, right? We'll proceed. Now let's say if I am trying to bring this Q point very close to P, you can check it here. If I will bring this point Q over here, that slope will decrease. If I will try to bring it or closer, will again get some another slope like this. Whenever this Q approaches to P and whenever it comes to very closer, then that delta y and delta x becomes very small, right. So we'll see what happens when delta x will be very small. Look at here, when I am coming to very small value of delta x, this is type of graph we had, and here we had P and here Q, right. So whenever I am saying delta x is very small, then all the time instead of that whole PQ range, I'll be getting one line which is tangent to the curve at point P, right. And whenever you want to calculate the slope, that slope of the line will be, it's like delta y upon delta x. So I'll write it here, slope of this tangent is delta y by delta x. This is represented by tan theta, right. So now whenever I am saying, whenever the slot delta x tends to 0, delta x tends to 0 means that interval is very small, right. And limit delta x tends to 0, it means dy by dx. When I write dy by dx, it means small change in y with respect to small change in x, right. So you can check it here. If I say limit delta x tends to 0, delta y by delta x, similarly I can write the same equation over here, that is dy by dx, right. So now slope of the tangent at any point gives the rate of change of y with respect to x at that point. Now Look at some basic derivatives of the basic functions. First rule, this is also called as some formulas, or you can say some rules for the differentiation or for the derivatives. Look at the first rule. I have chosen one constant c. Derivative of any constant is always c. Let's say if you are taking y is equal to 5. 5 is a number, we say it's a constant. So derivative of constant is always 0. So derivative of 5 must be 0. Look at the next equation. Derivative of x raised to n. This I am talking about. Right? Derivative of x raised to n with respect to x is n into x raised to n minus 1, where n is an integer but its value won't be 0. Right? Next, derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cos x square x. Derivative of sec x is sec x tan x. Derivative of cosec x is minus cosec x into cot x. Derivative of log x is 1 by x, and derivative of e raised to x is e raised to x. Once again, we'll all try to learn all the functions, because these functions are very important. If you don't know the formulas of the derivatives or differentiation, you won't be able to solve any sums based on the differentiation. So once again, we'll learn them. Derivative of constant is 0. Derivative of x raised to n is n into x raised to n minus 1. Derivative of sin x is cos x. Derivative of cos x is sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cosec square x. Derivative of sec x is sec x tan x. Derivative of cosec x is minus cosec x cot x. Derivative of log x is 1 by x, and derivative of e raised to x is e raised to x. Now, we'll utilize them. Now, rule number 1. Its derivative of constant is 0. Just now I explained about it. The derivative of any constant function is 0. Just now I taken one example. Let's say y is equal to 6. This 6 is a constant number. So dy by gx is equal to always 0. Why? Because c is a constant, or 6 number which I used instead of c, that will give you derivative 0. Right? So you can observe same over here. Next rule. Next rule is power rule. As I said, derivative of x raised to n is equal to n into x raised to n minus 1, where n is any rational number. Now, look at here. Just now we'll be taking, just now we have gone through the rule. Now we'll try to implement that. We'll take one example. Let's say it is given over here, y is equal to x raised to 4. What is the value of n here? It's 4. What is the power rule? Y is equal to x raised to n, and derivative of y with respect to x is n into x raised to n minus 1. So what is the value of n here? It's 4. Right? So what is the derivative of this function? Dy by dx is equal to, it's 4 into x raised to 4 minus 1, it's 3. So what should be the answer? It's 4x cube should be the answer of this function. Y is equal to x raised to 4. Right? Now we'll come to the second part. Second function is given as y is equal to 1 upon x raised to 5. Right? So again, you will be having confusion how to use power rule over here. So we'll do one thing. Y is equal to 1 upon x raised to 5. So is it okay if I'll write y is equal to x raised to minus 5? Right? So now n is equal to minus 5 over here. Again, I'll be going for the power rule. What is the value of n here? It's minus 5. So dy by dx is equal to, how much you get? Minus 5 into x raised to n minus 1. It's minus 5 minus 1. How much you get? It's minus 5 into x raised to minus 6. So what should be the answer? It's minus 5 upon x to the power of 6. Now look at the third equation. What is the function? Y is equal to cube root of x. How do you write this? Y is equal to x to the power of 1 by 3. Right? So now, what is the value of n here? It's 1 by 3. Again, we'll go for the power rule. Dy by dx is equal to, it's 1 by 3 into x raised to 1 by 3 minus 1. How much you get? It's minus 2 by 3. I'll write it here. It's 1 by 3 into x to the power of minus 2 by 3. I hope this power rule is very much clear. We'll proceed next. Next is constant multiple rule. Let's say we have two functions, fx and gx, right? I'll do one thing. One function is multiplied by some constant number. You can look at here, let's say fx is equal to c into gx, right? So, gx is multiplied by some constant, right? So, now we'll do one thing. Whenever we are going for third rule, that is constant multiple rule, we'll be taking constant out of the differentiation and then we'll use the differentiation rule, right? I'll show you one example. It is given over here rather, right? Y is equal to 5 into x cube. Which constant multiple here use? It's 5, right? So, in this R function, c is equal to 5. Now, while solving this, I'll be taking c out and I'll just differentiate x cube, right? How to differentiate x cube? It's very simple. Differentiation of x cube. It's again I'll be going for power rule. So, it's 5 into 3 into x square, right? Again I'll be going for the power rule. N is equal to 3 I said, right? So, x raised to n differentiation is n into x raised to n minus 1, which is 2, right? So, how much you get? It's 15 x square, right? This is nothing but dy by dx. Next, second function, y is equal to 3 by 2x. Y is equal to 3 by 2x. So, what is the constant? It's 3 by 2. What do you have here? It's x. Power, nothing is mentioned. Means definitely it must be 1, right? So, we'll solve it here. 3 by 2, it's constant, will come out. And differentiation of x is nothing but 1 into x raised to 1 minus 1 is 0, right? And x to the power of 0, it's always 1. So, you get just 3 by 2. So, what should be the answer? It's just 3 by 2, right? Third rule is clear. We'll proceed to next rule. Now, we are going for the sum rule. Look at here. Let's say fx given function is addition of two functions. Which functions are used here? It's gx and hx. So, f of x is addition of two functions gx and hx. Now, whenever I am going to calculate the differentiation of fx or derivative of fx, I will calculate derivative of gx separately, I will calculate derivative of hx separately and will add them, right. So, you can see one function over here, y is equal to x to the power of 4 minus 2 x square plus 2, right. So, what you are going